So hi guys, welcome to the calculus discussion of IIT JAM 2026 mathematics. In the previous videos, we had discussed about real analysis, we had discussed about ordinary differential equation, and in this video, we will be discussing about all the questions that came under the topic of integral calculus and limits, etc. So in this video, you can find out the timestamps of each of these questions so that if any point in this video, if you understand the solution, you can skip forward to the next question. So let us start with the first question. First question is basically, given a triple integral, we need to find which of these following integral is equivalent to the integral that is given to us. So for this integral to be same as any of the integral, the region that was defined should be same, right? For example, if you do a double integral, let's say dx dy upon a region, let's say a, and let's say the region is basically a square kind of region, 0 to let's say 1, and it is also 1. So if you integrate a function over this region, and if you integrate the same function over another region, let's say this region, so will the value be same? Value will not be the same. I mean, for some function it can be same, but for all the general functions it cannot be the same. So for the integration to be same, the region that we are talking about should be same. So basically, we need to see which of these options is corresponding to the same region that is described by this option, right? So let us first see which region is the given option, I mean given question suggests us. So in the given question, z must range from 0 to y must range from 0 to x, and x must range from 0 to 2. So in the xy plane, we can plot the thing first of all. I mean, we cannot draw a 3D diagram here, but in the xy plane, at least we can see that x is from 0 to 2. So 0, 2, 2. And if I draw line y equal to x, y is ranging from 0 to x. So like this strip, we are going forward, integrating. So basically, we are talking about this region. In the, at least in the xy plane, we are talking about this region, this whole region, right? Let us first eliminate the option by looking at the xy plane, because if the region is same, then xy plane region has to be the same as well. So I mean, if two options will be having the same xy region, then we will think about z. So starting with the first option, first is saying z should range from 0 to x. I mean, we do not care about z as of now. X is ranging from y to 2, and y is ranging from 0 to 2. So if I draw this region, y is ranging from 0 to 2, 0 to 2, and x is ranging from y to 2. So from y, so x is equal to y, we have to draw the line. So from y it is ranging to 2, like this. So strip is like this, and we have to move it like this. So the region, as you can see, is not the same, right? So this option is eliminated straightforward. Going to the next option, it is saying y is from z to 2, z is from 0 to x, and x is from 0 to 2. So if I see, I mean, here I cannot draw the xy plane directly because it is dependent on z as well. I mean, y is dependent on z. So let us leave this option as of now, right? Let us see about option 3. X is ranging from y to 2, z is from 0 to y, sorry, y is from 0 to 2. So here you can see that if I only talk about x and y plane, it is similar as the first option. And first option was not the answer because the region that was traced was this kind of region. So this is also a wrong option. So let us talk about option 4. Option 4, y is ranging from 0 to x is ranging from z to 2, and z is ranging from 0 to 2, right? So option 2 and 4, we need to check. We need to first of all see the xy region here, right? So the x region is z to 2. So it is going from z to 2. And the maximum value of, I mean, z is also going from 0 to 2. So in the xy plane, we can think like, I mean, we are going from 0 to 2 only in the x region, at least. In the y region, we are going from 0 to x as we used to go in the original question. So it might be a possibility, right? So in this question, if you focus on xz region, we can actually find out which is the answer. If I take it the xz region, so if this is x, this is z, if x is from 0 to 2 and z is from 0 to x, so we are tracing the exact same kind of region as we were tracing in the xy plane. So the region is this only. So here, if we talk about xz plane, z, x was ranging from z to 2 and z was ranging from 0 to 2. So we are talking about this region actually, not this region. So same region actually. So this region is conflicting basically. I mean, this is not the region of interest, because in the original question, uh, plotted the xz region for option 2 and option 4 now, and in the question the xz region was from 0 to 2 and 0 to y. So z is ranging from 0 only. Z is starting from 0 every time. It's going till y. So this we can see will not be possible, right? So option 2 is correct. So for question number 2 is easy as it seems difficult from the option, but it is very easy. You can actually solve this question without actually solving. So we are been given that there is a region, there is a triangular region. This is origin 0, 0, this is 1, 0, and this is 1, 1. This is a triangular region that has been given to us, and we have been asked to find out we have to integrate a function over this region. The area of integrating a function over this region. Function was f of x comma y. So we have to integrate this function in this region. But the twist is that this function is in the polar coordinate form. So we cannot integrate over normal range of x and range of y, right? You have to integrate over the polar coordinate region. So again, the same concept as question 1. If the region is similar, then the integration is same. If we are integrating f, let's say dx dy, from this you will put limit 0 to 1 and 0 to x, right? Dy dx. Now if you could write f dr d theta, and if you could put the limit of r and theta such that this region is covered, that means the area should be the same, right? So similarly, how we can do that? To cover this region, what we can do logically, we can have f dr d theta first, f r dr d theta, basically that is how it translates from the rectangular coordinate system to the polar coordinate system. And first of all, we can vary the r, right? R will range from, for the radius is root 2, right? If you can see, this is root 2, this distance is root 2, so 0 to root 2, and the angle here is pi by 4, so 0 to pi by 4. So this basically is talking about this region. It is not talking about the triangular region, because we are taking radius from 0 to 2, so it is a circular region. So we are talking about this region. So if we have this, we have to subtract this region, right? We have to subtract this region somehow, so that I can get that blue colored region. So from this, I need to subtract the something. So in these options, these two options are subtracting something. So these two options are already wrong, right? Now in these two options, we have to subtract something, and all the regions that are lying here, all the points that are lying in this region, the region of subtraction, all these points have radius ranging from 1 to root 2, right? The radius of this closest point is 1, and the radius of all these points are lying between 1 to root 2, right? So 1 to root 2, f dr r dr d theta, the same translation logic. But what is the angle value? Angle would range from, all of these points will have angle that will start from 0, that we know, and in this option you can see it will start from 0 only. But where it should go, cos inverse 1 by r or sin inverse 1 by r? We can solve the question like that. We do not need to exactly translate, because we will not have that much time. So all the points that are lying in this brown color region, what is the maximum value of your angle? If your r is 1, what is the value of your angle? Your angle has to be 0, right? because r equal to 1 only only is this only one point, right? This point only. Other point will have r greater than 1. So let us put r is equal to 1. So cos inverse 1 and sin inverse 1. So cos inverse 1 will give you 0. So 0 to 0 we are integrating. Sin inverse 1 will give you 0 to 1. Right? So for r is equal to 0, this is going from 0 to 1. The angle is going from 0 to 1. But for r equal to 1, the angle should be only, there is only one angle, there is only one point. We do not need to integrate over the region. So basically, if you can see like that, the answer is option number 2. Right? This is how you can efficiently solve a question in the examination without actually solving. Or in other word, you can think like, cos inverse 1 by r, if r ranges from 1 to root 2, cos inverse 1 to cos inverse 1 by root 2, that is cos inverse 1 is 0, and this is pi by 4. It is ranging from, similarly if you convert, the sine inverse angle will range from pi by 4 to pi by 2. But here no angle, no point has angle from origin that is greater than pi by 4. So this is actually wrong if you think like that. So that is how you can solve the question in only one page. There is no need for extra pages. Let us move to question number 3. In question number 3, we have been given a semicircle and it is rotated by an angle this. So, we need to find out the area of the region that is traced out by this rotation. So let us first understand what is this semicircle. So if I square it on the both side, I'll have y square equal to 6x minus 5 minus x square. So x square plus y square minus 6x is equal to minus 5. If I complete this circle equation form, I can add plus 9 both sides, right? So that it will become x minus 3 square plus y square is equal to 2 square. So it is basically the circle that has center at 3, 0 and radius of 2. So the maximum point here is 1, 0, minimum point, and maximum is 5, 0 here. And because it is in this form, so it is a semicircle. Because if I trace the exact circle, the circle will have some points which have positive y value that is lying above the x-axis, and half of the points will have negative y value. But if I am given the circle in this form, that means y cannot be negative, because output of the square root function has to be positive always. So we are not talking about the lower region at all. So that is why this is not a circle but a semicircle, right? So if I copy paste, because I'll not have space here, if I copy paste this region, yeah, and it is saying we are rotating this semicircle by an angle pi by 2 in the plane. We are not rotating outside of the plane, we are rotating in the plane only. But we are rotating about origin and by an angle pi by 2 in the clockwise direction. So we are rotating the semicircle like this. So after pi by 2 angle, my semicircle will look like this. And this point will be 0, 3, it is 0, 1, and it is 0, 5. So the region that is traced by the circle is basically, let me draw it. So the region that will be traced by a circle is this region. If I draw it, just a minute. So this is this region particularly. So how can we find this region? There are multiple ways of finding. We can use calculus, or without calculus also one can find this. Let me tell you the approach of finding the region without calculus first. And using calculus, you have solved the questions already so much. So basically, if you think this region, if you have studied mensuration in your lower mathematical classes, mensuration, there would have been given a complex shape like this. Let's say there is a rectangle and there is a semicircle at the end. Find the region. How could you do it? You could first find this, and then this, and then this, and then you have added the regions. We will do a similar logic here. So basically the area that was traced. So I know this area, right? I know this particular area. What is this area? That is pi r square by 2. And pi into 2 square upon 2, that is 2 pi. I know this region already. So my area is greater than 2 pi at least, I know. So these options are eliminated. Now, if you apply the same logic, if I put the circle like this, the remaining area I can imagine is has to be greater than 2 pi. From the diagram itself, if I'm drawing the diagram accurately, I can directly see the remaining area is greater than 2 pi. So it cannot be 4 pi even. The correct answer is 6 pi directly. But let us solve it. Let us solve it. This region, the remaining region, let me just trace it in orange. I can find out this orange region. Basically, this is nothing but a circle if I complete it. This is nothing but a circle if I complete it. So if I subtract the area of outer circle minus inner circle, I'll get the whole area of this whole track, right? Area of this whole track I can get. And if I do 1 by 4, I'll get the area of this brown track that I just drew, right? But your doubt can be why this will be a circle. Why this will be a circle? Because this is nothing but all this point is at a distance of 1 from the origin, and this point is rotating by pi by 2. That is, this region is at a distance of 1 from origin. That is nothing but a definition of circle. Similarly for this region, right? So pi of outer circle will have radius this. So that is, this point was 5 comma 0, so radius was 5. So pi r square minus inner circle pi into 1 square by 4 is my orange area. So that means this orange area I'll have. Now from this orange area, if I subtract this semicircular region, this region, let me just draw it using a different color. If I subtract this region, then I'll have the area of interest that I have to add to 2 pi, right? So subtract what? 2 pi. This I have to add to plus 2 pi. This I have to add to this value, because this particularly is the area of this orange region. Because this is the area of that quarter track, and from that I am subtracting the semicircular area. So this is the area of my this track, right? This remaining brown track that I have to add to 2 pi. So I have to add this and this. So let us add it. So 2 pi plus 25 pi minus pi by 4 plus 2 pi. Sorry, minus 2 pi. So this is nothing but 24 pi by 4, that is 6 pi. That is my answer. Let us move to the next question. This is, an integration is given to us, and we have to find the value of this integration as x tends to infinity. So how can we think about it? There is nothing extra given. It is a plain simple question. So if you think in the direction that we have limit x tends to infinity, some function of x this, and this is a function of t dt, then a thing that clicks in your mind is to take the derivative so that I can take it inside. So here the derivative will not work, because what is the purpose of taking the derivative? Why are we interested in finding the derivative of this thing? We are asked to find the value, so that will not work. So if you think like that, so there is no other option apart from finding the integral itself. And this integration we can do, right? We know integration of e power t sine t, things like that. So limit x tends to infinity 0 to x e power minus t sine t dt. Now this modulus of sine needs to be opened for me to perform integration, right? Because I don't know how to perform integration of mod. We have not taught that thing already. So how can I open the mod of sine t? So for that I need to know the signs of sine t, when it is positive, when it is negative. So if I draw the graph of sine t, sine is positive in 0 to pi, negative in pi to 2 pi, positive in 2 pi to 3 pi, and so on. So I can write this integration precisely as limit x tends to infinity. You can write this integration 0 to pi e power minus t sine t mod, plus I can break in the pi intervals, pi to 2 pi e power minus t sine t dt, and so on, right? But what I know that in the first region the sign is positive, so I can write it directly as e power minus t sine t dt. In the second region it will be negative, because sine's value is negative, so I can take a minus sign outside, pi to 2 pi e power minus t sine t dt. And for the third region, it will be positive only because it is alternating, as we can see here. 2 pi to 3 pi e power minus t sine t dt plus 3 pi to 4 pi, sorry, not plus, it is minus 3 pi to 4 pi e power minus t sine t dt, and so on, right? I mean, we cannot, I mean, we can remove limit extends to infinity because we are taking sum till infinity. So that is same as taking x till infinity. So we can remove this thing as well. So let us first find out what is the integration of e power minus t sine t, right? First of all, before solving this. So let us find out the integration of e power minus t sine t. So how to perform this integration? We can perform this integration by using integration by parts. So if you have practiced questions of integration by parts, these questions are very common in integration by parts, e power t sine t, x log x, and etc. So this will be equal to, how to perform integration of product of two function uv is, you can take u outside, then integration of v dv minus derivative of u into integration of v dv's whole integration, right? So the first function here is e power minus t. So I can take e power minus t outside. E power minus t integration of sine is minus cos, right? Minus integration of e power minus t is minus e power minus t. So plus e power minus t. And integration of v is minus cos t again dt. So e power minus t cos t. I can take this minus sign outside. Minus e power minus t cos t dt. So I can again perform this integration by part for this particular function. So it will be what? E power minus t integration of cos is sine t minus derivative of e power minus t is minus e power minus t. So plus e power minus t integration of cos is sine. Now you can see that this and this are same. So I can rewrite this thing. If I take this as I, a variable I, so I is nothing but I is equal to this thing. So minus e power minus t cos t minus e power minus t sine t plus I, right? So it is I is equal to minus e power minus t cos t minus e power minus t sine t minus I. So I can write I as 2I. 2I will be this. So I equal to 1 by 2, or in other word minus 1 by 2, or in other words minus e power minus t by 2 cos t plus sin t, right? Now I can write this integration. So let the value be s, let the sum be s. So s will be equal to what? 0 to pi, this value. So minus e power minus t by 2 cos t plus sin t, perform till 0 to pi, plus same thing. I mean the other thing is the integration is same, the sign outside is different. So this is minus e power minus t by 2 cos t plus sin t, 0 to pi to 2 pi, then plus this thing from 2 pi to 3 pi, and so on. So if I rewrite it, so I can take from all of this I can take minus 1 by 2 common. So minus 1 by 2 e power minus t sin plus cos, I am not writing it, 0 to pi, and if I take minus 1 by 2 common, everything remains the same, e power minus t bracket thing, and from pi to 2 pi, plus e power minus t the bracket thing from 2 pi to 3 pi, and so on, right? Now this bracket thing, let us decode this bracket thing. So the cos t plus sin t, if I put even multiple of pi means 0, 2 pi, 4 pi, etc. If I put even multiple of pi, that is 2k pi, what it will become? Sine of even multiple of pi is 0 already, and cos of even multiple of pi is 1. If I put odd multiple of pi, let's say 2k plus 1 pi, that is nothing but pi, 3 pi, 5 pi, like that. So sine is again 0 obviously, but cos is minus 1. So it can take the value minus 1 and 1 only. So if I expand it, minus 1 by 2, e power minus pi, odd multiple of pi is minus 1, minus even multiple of pi is 1. So e power minus 0 into 1, right? This is the first value, minus even multiple of pi is we know e power minus 2 pi into minus 1. Sorry, in even it is plus 1. Minus e power minus pi, it's minus 1. And you can write it like this, right? And you will see a pattern here. What is the pattern? If I do not want to overflow it, so let us erase the signs, this thing's derivative. Let us rewrite what we found. So let us write the first fourth term only, minus 1 by 2. So it is minus e power minus pi, minus e power minus 0, so minus e power minus 0, and then minus e power minus 2 pi, and this is negative, negative sign is getting positive, and then outside there is a negative sign, so again negative sign. So minus e power minus pi, and if I would have solved this thing, so this would have become what? E power minus 3 pi plus is there, and I have to put the odd multiple in this term. So odd multiple is getting minus 1. So minus 1 minus e power 2 pi, even multiple is 1, so 1. So if I write it, so it becomes minus e power minus 3 pi minus e power minus 2 pi, and so on. You can see there is a pattern here, right? Minus sign is common, so I can take the minus sign outside. 1 by 2, I can see that for 0 I am having one term, for pi I will have two term, for 2 pi I will have two term, for 3 pi I will have two terms. So it is like 1, e power 0 is 1. I have taken minus sign outside, so plus 2e minus pi plus 3e minus 3 pi, not 3, plus 2e minus 4 pi, and so on. So we need to compute this sum, basically. That is what it was asking us. So what is this sum? If you can see it, if I rewrite it actually, 1 by 2 plus, if I multiply this and if I multiply this to them, so it is e power minus pi plus e power minus 3 pi plus e power minus 4 pi, and so on. I mean, I made a mistake here. And this is nothing but a geometric progression, right? Geometric progression having a ratio as e power minus pi. So how to find the sum of geometric term? We know it is a divided by 1 minus r. So this is equal to 1 by 2 plus a is e power minus pi, 1 minus r. 1 minus r is e power minus pi. So it is nothing but 1 by 2 plus, I can multiply e power pi numerator and denominator. So it will be 1 e power pi minus 1. So it is 2 into e power pi minus 1 plus e power pi plus 1. So this is my answer. So this is option number 2, as you can match from here. So if you had not understood it, you have to write along with me to understand, right? Next question, we can again solve it smartly. If you do not want to solve it actually, you can again solve it smartly. So what it is saying that there are two spheres. We have to find the intersection of area volume of the intersection of these two solid sphere. So let us write this solid sphere equation here: x square plus y square plus z minus 1 square is equal to 4. This is my sphere, at least outer part of the sphere. So the center is at 0, 0, 1 and the radius is 2. For the other sphere, center is at 0, 0, minus 1 and radius is 2 again. So if I draw the axis, so this is x axis, this is z axis, and y, let us not draw it for simplicity. Y will be bulging outwards. So my center of one sphere is lying at this point, 0, 0, 1, but it is of 2 radius, so it will go till this point where the center of my second circle lies. The center of my second sphere will lie here, first sphere will lie here, but both of them will pass through this point. So this is my bottom sphere. This is my top sphere. Right, so this is sphere S1, this is sphere S2. Now this is their area of intersection, right? So if you imagine this in 3D, as you can see here, there are four regions formed. One is this region, one is this region, one is this region, and one is this region. If you imagine it in 3 dimension, there are 8 regions formed actually. So it is 8 times the integral. But I mean, that cannot be true as well. I mean, you can integrate the this region as the first region and this region as the second region, and you can have two as the coefficient, so that you should not get fooled by it. So how can we confirm whether it should be multiplied with 2 or multiplied with 8? Because here the limits are being taken from 0 to some value, then 0 to some value. So it is talking about the first quadrant. First quadrant. So only the first quadrant area is calculated. So what should it be multiplied? It should be multiplied with 8, right? Because I'm only taking the first quadrant area, positive x and positive y. Then there are 8 such pieces. So these options are already ruled out. Now, if there are 8 such pieces, what would be the limit? Here we are taking limit of y from 0 to 2. So in the intersection area, what is the limit of y? 0 to 2 or 0 to root 3? Okay, so let us, I mean, here in this diagram, y is not clearly visible. So let us first find out the region of area of intersection, I mean the coordinate of intersection. So here we can see that they will intersect at the x-axis as well, right? So if I put x as y as 0 and z is 0, because in x-axis y and z is 0, so what will be the my value of x? So x will be nothing but root 3, right? Similarly, for this, root 3, I mean, though two values are same because they are intersecting. So they are intersecting at here. So in the y-axis also, if I find what is the coordinate of intersection, in the y-axis also it will be root 3. So in the y direction, we cannot go after, I mean, outside of root 3, because that is not the area of intersection. In precisely, that is not the volume of intersection. So it should go from 0 to root 3 only. So this option is also eradicated. So this is my correct option. So the next question is question number 6. Question number 6, we have to find the summation and we have to do the integration after that. So let us write this sum first of all. K is equal to 1 to infinity log 2 power k x k minus 1 k minus 1 factorial. So this seems a little bit familiar, right? Summation of x power something and then that factorial. What is this? We know the integration, I mean the expansion of e power x, right? Taylor series expansion. It is 1 plus x square by 2 factorial plus x3 by 3 factorial. So it is like summation of k is equal to 0 to infinity x power k by k factorial, right? So it is similar to that, but there is some twist, right? So let us just rewrite it. I mean, if I have x raised to the power k, a variable raised to the power k, and that factorial, then I can convert in the e power summation. So what can I do? Can I take log, because this is unwanted here. I mean, this is hindering my purpose here. So can I take log inside kx somehow? So can I do so? I can do so, right? 1 to infinity. I can write log 2 power k minus 1, then x raised to the power k minus 1 by k minus 1 factorial. So if I take log 2 outside, because log 2 is now independent of k, so log 2 outside, sigma k is equal to 1 to infinity, I can write x log 2 k minus 1 by k minus 1 factorial. So if I rewrite it, it is log 2. If I put k is equal to 1 here, so x, this thing raised to the power 0 and this thing raised to the power 0. So it is 1 plus x log 2 plus x log 2 square by 2 factorial plus x log 2 cube by 3 factorial and so on. This is nothing but the definition of e power x only, right? I mean, e power x is 1 plus x square by 2 factorial and so on. So if I compare this thing with the previous thing, I can directly see that it is e power x log 2. Now, this summation becomes log 2 into e power x log 2. What I was asked? I was asked the integration of this thing. So if I integrate log 2 e power x log 2 dx from 0 to 1, Let us take x log 2 as t. So log 2 dx becomes my dt. So I can rewrite this thing as e power t dt. So the answer becomes e power t plus c. And I can substitute t back. T is my x log 2, e power x log 2 plus c. And if I take the limit as 0 to 1, c will not matter, right? Because c is the same thing. So e power c will cancel out. E power log 2 minus e power 0. That is 1. And e power log 2 is nothing but 2, because e power log of any number is that number only. Minus 1 is equal to 1. So the answer to this question is 1. Next is basically an integration. And yeah, so we know these functions. This function is basically a modulus function that has two definition. It is x minus 1 if x is greater than equal to 1. It is 1 minus x if x is less than 1. And for GIF, we know we can have the definition of GYF if we split across integers. That means GIF of x is basically 0 if x is belonging to 0 to 1 open, 1 if x is belonging to 1 to 2 open, 2 if x is belonging to close to 3 open. So we can split, we can have the value of these composite functions. Not composite, but this functions which are not directly resolved. I can resolve this function if I split the domain across these intervals. And here also I can resolve this x minus 1 mod if I split across this interval. So let us split this 0, 3 across 3 interval, that is 0 to 1, 1 to 2 and 2 to 3, right? So at 0 to 1 I will have resolved this value as well, because it will have this definition because it is x less than 1 in this region. And for this region I'll use this value of this first function, and for the second GIF I know the values across these intervals. So that is my agenda. So let me write it. So 0 to 3 mod x minus 1 minus x mod x dx is basically 0 to 1 this thing, 0 to 1 this mod, 0 to 1 to 2 this mod, and 2 to 3 this particular function, not mod actually. So 0 to 1, if I split it, it will become 1 minus x into, in 0 to 1 GIF becomes 0. I already told you that. So it is nothing but 1 minus 1 dx only, 1 minus x dx. In 1 to 2 x minus 1 I can write it x minus 1, and GIF becomes 1 only, so minus x dx. In 2 to 3 it is x minus 1 again, but GIF becomes 2, so minus 2x dx. So if I solve it, it is basically x minus x square by 2, 0 to 1, plus this will get cancelled out, so minus x 1 to 2, plus it is nothing but minus x minus 1, so it is minus x square by 2 minus x 2 to 3, right? Now if I put the value, it is 1 minus 1 by 2. I can take the minus sign outside, so minus x, so 2 minus 1. I can take here also minus sign outside, so 3 square by 2 plus 3 minus 2 square by 2 minus 2. So it is 1 by 2 minus 1 minus 9 minus 4, 5 by 2 plus 1. So 1 by 2 minus 1 minus 5 by 2 minus 1. We can solve it basically. So it is minus 2 minus 2, it's minus 4 actually. Minus 4 is my answer. Let us move to the next question, that is question number 8. In question number 8, I have to find this particular summation. So what are the approaches? So first approach, you can see that you can convert this into integration format and you can solve the integral, but converting this to integration format is a little bit trickier. The second approach that you can think is that we can use the sandwich theorem. If we find the bounds of this this summation, let's say this summation lies between f of x and g of x, and if as limit n tends to infinity, if these two terms are going to the same value, and then s should also be going to the same value, right? So we will follow that approach actually, and let's try at least if that works or does not work. So I know that this particular a term in this sum can be given by n square by k upon under root of n power 6 plus k. So this is a general term in this particular summation. Now what can be the upper bound? Upper bound means I have to maximize things. So this particular thing is less than n square plus n, right? And this can be my upper bound because I am minimizing the denominator and maximizing the numerator. Similarly, I will maximize the denominator here, n power 6 plus n, and minimize the numerator, that is n square. So this is my upper bound and lower bound. Now if I apply the summation sign, if I sum it from k is equal to what? K is equal to starting from 1 to infinity. Here also I can summarize not infinity, from n actually, because this is basically, I am not talking about this right now. I am talking about this sum right now. So the sum is going from 1 to n, right? This particular thing is same as this particular thing right now. So k is equal to 1 to n, k is equal to 1 to n. So let us represent this sum by the symbol s. So s is less than or equal to, let us do this. So it is nothing but n multiplied by n square plus n by under root n power 6, that is n cube, and it is nothing but n cube by n power 6 plus n, right? So the summation will lie between these two values always. So if I rewrite it, it will become 1 plus 1 by n, and this will become 1 by 1 plus 1 by n power 5. Now what is asked? Limit n tends to infinity, s is asked. So if I use limit n tends to infinity both sides, limit n tends to infinity, limit n tends to infinity, we can see that if n is going to infinity, this particular thing will go to 0. So it is 1 by 1 is, it will go to 1. As n tends to infinity, this particular thing will also go to 1. So if this sum is lying between these two bounds, and as n tends to infinity, these two bounds are going to 1, then that means as n tends to infinity, the sum should also go to 1. That is the sandwich theorem basically. So the answer to this question is 1. Now question number 9, we have to perform a double integral here. So the double integral is f of x comma y dy dx over an area A. Here we have been given f of xy as x, so x dy dx over an A, and the area is the triangular region that has this boundaries. So let us draw this triangular region first. 1 comma 2, so 1 comma 2, basically this point, 1 comma minus 1, this point, minus half comma half, so minus half comma half, so basically this point. So we have to perform integration over this triangular region. So if I draw this triangular region somehow, so here my x is ranging from minus half to 1, right? My x is ranging from minus half to 1. What my y is ranging? Y is ranging from this below line to this upper line, right? If I take this kind of strips, that will be done. So y will range from this value to this value. So let us find the equation of these two lines. Equation of, this bottom line and top line. So the bottom line's equation is nothing but standard. We can see that y minus y1, let us take this as a point, y minus y1 by x minus x1 is equal to slope. Slope of this line is what? We can calculate the slope. Slope is half plus 1 by minus half minus 1. This is nothing but minus 1. So y plus 1 is equal to 1 minus x. So this line is nothing but y equal to minus x. As you can see, the slope is negative 1 and it is passing through origin. So y is equal to minus x is this line. What is this upper line? Upper line, we can actually again do the same thing. Y minus 2 by x minus 1, taking this as a point. Slope of this line is 2 minus half by 1 plus half. This is nothing but 1. So y minus 2 is equal to x minus 1. So y is equal to x plus 1. So this is the line y equal to x plus 1. So now you can see my y should range from minus x to x plus 1. So minus x to x plus 1. So now I can easily perform this integration. So let us perform this integration. First, integrating x with respect to y. So this is minus 1 by 2 to 1 x into x plus 1 I mean, this is nothing but y from minus x to x plus 1 dx. So it is minus half 1 x, x minus 1, minus of minus x, that is 2x plus 1 dx. This is nothing but minus half to 1, 2x square plus x dx. So you can do this basically 2 into x cube by 3 minus half to 1 plus x square by 2 minus half to 1. So it is nothing but 2 by 3, 1 cube minus 1 by 2 cube, that is 1 plus 1 by 8 plus 1 by 2, 1 minus 1 by 4. Now that is 2 by 3 into 9 by 8 plus 1 by 2 into 3 by 4. 3 3 ja basically, and yeah, we'll take the 8 as a denominator. We will not cancel it because we have to add it with the second term as well. So 8, 6 plus 3 basically, it is 9 by 8. So 9 by 8 is basically 1.11 something. So you can, the answer here will be 1.11 if you round off to 2 decimal places. So welcome to question number 10. Question number is saying to find us the volume of the tetrahedron that is bounded by this plane and this plane. So okay, let us first trace out the region. How to find out the volume of any surface? Volume of the surface is basically triple integration of dz, dy, dx, and the limit that you have to put for that region, right? So to solve this question, we have to identify the region first. So let us first understand this plane, the fourth plane that is given to us. Let me draw the coordinate axis first, x, z, and y. So this plane is intersecting x, y, and z at what point? Let us find out. For point on x-axis, we have to put y and z as 0. So if we put y and z as 0, I will get 70 by 12, that is approximately 6. Right? If I do this same thing for y, that will be 70 upon 8, that is approximately 9. And for z, it is approximately 12. So this plane is passing through x, y, and z like this. And we have been given bounds of x, y, and z as well. X is equal to 1, y is equal to 2, z is equal to 3. So the volume of tetrahedron bounded by these planes and this region. So how to understand this? So let us understand it in xy plane first of all. So what is happening in the xy plane first of all? So let me just draw the xy plane. So x and y. In the xy plane, z is 0, right? So let us put z as 0 here. So 12x plus 8y becomes 70. So let us draw this line, 12x plus 8y equal to 70. So at x it is passing through 6, at y it is passing through 9. So basically I can draw it like this, right? Now x is equal to 1 somewhere here, y is equal to 2 is somewhere here. If I draw these lines as well, what is the area that is bounded by these 3 lines here? If we know that, we can extrapolate it to the higher dimension. So this is the area, right? This is the area that is bounded. This is the area that is bounded by these two regions. So if we have to put the limit of this area will range from x equal to 1 to the plane, right? X is equal to 1 to the plane that allows up to 70 upon 12, right? What the limit of y? Y will go from y equal to 2 to this upper limit, upper plane region. So if I just clean it up a bit, y is going from 2 to whatever the plane allows, like this, right? So y will go from 2 to whatever the plane allows. So what the equation of this line here? This one. So y is equal to 70 minus 12x upon 8. Now similarly we can do for z. So z will start from 3 and it will go from till 6z. I can rewrite this. 6z equal to 70 minus 12x plus 8y. So z is equal to 70 minus 12x plus 8y upon 6. I mean whatever the plane allowed, just like in this case whatever the line allowed, whatever the plane allowed, so up to this. So if I have to write this integral in the proper form, in the proper expanded form, I can write this integral as integration 1 to 70 over 12, integration 2 to 70 minus 12x upon 8, integration 3 to 70 minus 12x plus 8y upon 6 dz dy dx. So we have to solve this integral to get the answer to this question. So let us try solving this integral, right? First integration is with respect to z. So it will become what? 70 minus 12x plus 8y by 6 minus 3. This is my answer to the first integral dy dx. We can copy paste the limit, not required as of now. So let us do this. So let us solve this inner thing. Let us simplify this again. So I can take 1 by 6. Okay, 70 minus 18, that is 52. 52 minus 12x minus 8y upon 6 dy dx. Y is from 2 to 70 minus 12x upon 8. 70 minus 12. I can take the 1 by 6 outside because that is no longer needed. So 1 by 6 times 1 to 70 over 12. I can solve the inner thing. So 52y minus 12xy minus 8y square over 2, that is 4y square dx, and limit of y is from 2 to 70 minus 12x by 8, right? So 1 by 6, 1 over 70 by 12, that is 52. I mean, this is a little bit complicated to solve. So 52 into upper limit of y minus lower limit of y, that is 70 uh, minus 12. Okay, let us do one thing. Let us simplify this in other page, and then we will come back, right? 52y minus 12xy minus 4y square, and we the limits of this are 2 to 70 minus 12 upon 8, right? So let us do this. 52 into 70 minus 12x upon 8 minus 2 minus 12x, same 70 minus 12x upon 8 by 2 minus 4 70 minus 12x upon 8 whole square minus 2 square. So the calculations are, I mean, it is lengthy. So 52 into 70 minus 16 is what? 54, right? 54 minus 12x upon 8. And this is the same thing. So second one. So I can rewrite it as 52 minus 12x minus 4. 70 square, this is 4900 minus. So this is my final expression. So if I put it in the answer, that is minus 54x square plus 681x minus 1971. I can solve it, right? So this is my final expression. I can solve it basically. So you can actually solve it, and it will give you the final answer. I'm not solving it here. You get the idea of how this question will be solved. So the next question is question number 11. In question number 11, we have been given a function f of x, and we have to find the derivative of this function at x equal to pi by 4. So we know for a fact that if f of x is equal to, I mean, some function g of t dt, and the limits are from phi of x to psi of x, then the derivative f dash of x is basically, you do the derivative of the upper limit multiplied by g of, you have to put that function minus the lower limit's derivative into g of, you have to put that lower limit inside the function. So it is like that. So it is of that format. So we have to first solve this thing. Then we will think about this approach that I told you. So let us solve this. So the inner integral is 0 to log y e power minus half. So I can bring e power minus 1 by root 2 because that has nothing to do with this dt, and then we will think about dy, right? So this is basically t minus t cube by 3. If I put the limit 0 to log y, so it is log y minus 0, so log y minus log y whole cube by 3. So if I rewrite it, the inner thing, the inner thing becomes f of x is equal to 0 to e power sin x multiplied by log y, we have e power minus 1 by root 2 as well, e power minus 1 by root 2 log y minus log y whole cube upon 3 dy. So it is of this format right now. I have a function of other variable and integral of that variable, and in the limit I have function of x. So 0 is, I mean, we can ignore 0. 0 is a function of x, but this term will get cancelled out. We have e power sin x in the upper half. So f dash of x is basically e power sin x, derivative is e power sin x cos x multiplied by, I can put e power sin x in terms of y, in place of y. So that is e power minus 1 by root 2 multiplied by log e power sin x. Now we know log e power something, let's say x, is basically x only, right? So log e power sin x is sin x minus log e power sin x cube, that is sin x whole cube, sin cube x upon 3. So this is my f dash of x. So f dash of pi by 4 is 1 by root 2 e power 1 by root 2 into e power minus 1 by root 2, then 1 by root 2 minus 1 by root 2 whole cube. So 1 by 3 times root 2 whole cube. So this is my answer. So I can simplify this further. 1 upon root 2 e power 1 by root 2, and this thing will get cancelled out, right? 1 by root 2 minus 1 by 6 root 2. So I can multiply this thing. So 1 by 2 minus 1 by 12. So that will be equal to 12, and 6 minus 1, 5 upon 12. So that is 0 0.48 around something. Yeah, not 8. 50 is 12, 4, 48, 20. So approximately 0.42 is my answer to this question. So with that, we have finished discussing all the problems that came under limits in calculus. If you like this video, you can share it among your friends, like the video, subscribe to the channel, and also mention in the comment section below. So thank you guys.